going to just give a presentation of how we see the cloud changing financial services within the context of our own business model. And what we'd like to do is actually to bring up an application that we've built actually together with Elastacloud, which is really showing the capability of the cloud both as a source of data and a source of high-performance compute, which increasingly, actually, I'm going to run ahead of myself, so apologies, but increasingly in this increasingly regulated environment that we live in post the financial crisis of 2008 and arguably the second financial crisis of Europe, is going to become even more necessary all the way down to the chain, right to the smallest hedge funds, which before would have actually been more or less exempt from that sort of scrutiny. Okay, so a little bit about Derivitec, who we are, what we do. So we've been in business for 1 year. So we were founded in December 2011. And when I came from an investment banking background. I've been actually 12 years, all told, through Credit Suisse, Goldman Sachs, and UBS. That was my last bank. And when I started this company, I was asking myself the question, okay, why do people use third-party derivative software and what are they actually looking to get out of it? And so I did a great big deep dive, or at least I hope it was a deep dive into what people are currently offering and who's buying what where. And I actually got pretty scared by this, right? Because the one thing which occurred to me is that if you want to make any money out of that business, then you have to do it in scale. You really have to be selling your software on a sort of desk-by-desk basis, frankly, within the front office space. And those front office traders are going to be demanding exactly the same sort of capabilities they would have had, operating in the largest investment banks. So they're going to need to have high-performance grids. They're going to need ready, available market data, which is being cleaned up. And they're going to expect it to be working seamlessly. And the one thing you don't want to have happen is if you're distributing over all these little desks, over all sorts of different operating systems, some people operating in XP, some operating in Windows 7, who knows, some people operating in Windows 8 one day. You don't want them to suddenly say, well, this doesn't actually install properly because it's a 64-bit build versus a 32-bit build or some nonsense like that. And so, well, reasonably nonsense, right? Annoying. So at that point, I realized, well, the best thing to do, of course, is to have this sitting elsewhere in an environment which I can control. And then really the penny dropped because I say, aha, well, I can have lots of data. I can have the ability to distribute jobs over nodes. And here's the great thing. It's not going to cost me that much to do it initially as a demonstration package. And it's not going to cost my clients very much to do it initially as a demonstration package. But when they build out, they can actually build out with us. And we can actually, benefit from the cost savings together. So, as it says here, this is the sales pitch, so apologies, there won't be too much of that. The central philosophy is ease of use. You really want to be the case that I don't have to hire an IT person, respect, to go and install the application over all my various different machines and to actually manage that process and then to install it over a cluster and to manage all that as well. No, I actually want to be up and running within minutes. So I can actually concentrate on the business, me, the trader, of actually trading and concentrating on the bottom line. So that really, again, is to us, I think, the chief selling point of the cloud in terms of our clients. Apart from all of the actual capabilities it gives you, which hopefully we shall show later, it's just the fact it's really easy to manage that. Okay, this is, I think, not ready for this audience, but there is a point to this slide, so I'm not going to actually, by the way, this is heavily debatable. But actually, when I talk to people outside this room, and I say, what is the cloud? I say, oh, it's a database, right? I just stick my data there. I don't want to put my data in the cloud. It's all going to be insecure. What do you mean it's sitting in Ireland? I'm sitting in London. I don't want to have that sort of regulatory problem. A lot of people actually don't have a clear perception, strangely enough, of what the cloud is. And what's really frustrating about that, and it's something that we, together with Microsoft and Elastacloud, are trying to educate people about, is that the cloud is offering some distinct services, all of which have got an immediate application to the financial industry. So if we just look within the Windows Azure space, and I think about what are the actual compute resources I can use. Again, this is not the complete list, so apologies in advance, but if we just go for the web role, worker role method, web role. Why would I want a web role? Because I want supply market data, right? I want to go to a site and I want data to come down. And I want to be able to consume that data either within an app, or maybe I actually want to consume it directly as a reference into my Visual Studio project, which my IT people can then actually consume for building their own apps. So that's one thing that we do. Worker roles are absolutely crucial if you want to have high-performance computing. You want to basically take a trading book, send it off, and have lots and lots and lots of different workers picking up those jobs, computing the risk in an embarrassingly parallel manner, and streaming the results back, which is a non-trivial process, which Andy will talk about in more detail. But then, of course, we've got storage, right? So you want to have a large amount of data. And it's actually very interesting. People, I think, at least 3 times it was mentioned during the day that don't stick everything in a database. I could not agree more. Most of our data sits in tables. It's great. I have 100 terabytes of this stuff. I can actually take market data, derive market data, and I'll explain what that means with respect to an example, going back 10 years over everything trading on exchanges in the US, Europe, and Asia. I can have it sitting in table storage. And I don't care that it's vast, because I can just use a little context for actually putting that information very quickly and efficiently and downloading it to an app. And nobody has to worry about storing that data on site. And of course, they can also manage their own data through that process as well. And then, of course, you have the relational database. This is a little bit more controversial in the context of the financial industry, because this really does speak to trading books. This is, you want to see something like, how did that book perform over this period, and what changed in it, and why was that? So you really are kind of talking about relational joins all the time. This was something I did a lot of at Goldman Sachs, by the way. People aren't desperately happy about having that data, actually that trade-level data, in the cloud. It's not a no-no. The FSA is not saying you cannot do it, but it's the sort of thing that we are actually at the moment veering away from. So we'd very much talk about a hybrid solution when it comes to our cloud offering, which Andy will also talk about, which is where we think that it's good to have a mixture between the data you really want to keep on premise, as in the economically sensitive data, the data which is public market data, and really to be using the cloud for the most part as a computational resource. But the point is that all of this functionality has an immediate application to finance. And here's the thing, as you all know, it's on demand. We don't actually charge anything for our software, per se. Okay, we do charge something. We charge for the service. So if somebody is actually using a compute resource, it depends how much compute resource they want. If they're taking down a large amount of market data, it depends on how many hits they make to that market database. But again, it's very much an on-demand model, and it's also a license model, by the way. Okay, so I suppose I've already spoken to this, but this is like a little bit more granularity about why should finance use the cloud. And again, I guess it's really directed at the finance audience rather than this audience. But actually, I should have asked it. Is there anybody here from finance? Okay, right. So you can disagree with it or not. That's the case with me. Here's my view on why finance should use the cloud. It basically gives you what you need when you need it, and you pay for what you use. So if we just drill down into data, why are we so obsessed with data in finance? Well, because it's really useful, and we actually need it. Okay? We need to run strategy backtesting. We need to see how well this trade that we want to actually sell in the markets it has performed. Perform a case study around that. Say, look, if you invested in this insurance portfolio over the last 5 years, you would have been way in excess of the market. Fantastic. You need data. VAR, value at risk, or credit value adjustment as well. Very nasty, detailed calculations. You have to go back day by day by day by day by day. Here's how it changed. Here's how my portfolio changed. Here is where, if there's a 95% movement, here's how much money would be lost in that particular circumstance. Here's how much money I've got to keep aside in order to keep the regulators happy. That is a very data-intensive calculation. Again, immediately available from the cloud, provided, of course, you have the data sitting there already. And then, of course, the third point, which is, day by day, you want to stay in line with the market, right? Everywhere, every day. You want to be guaranteed of that. You don't want your data to go missing. And so that, again, provides that capability. Compute, I think, is really more about what we're going to be talking about here. Again, I've already mentioned this. It's the ability to scale your resources to a large number of machines. So you get billed for what you use. So the classic situation of having an investment bank which has got 10,000 cores, running its risk, And then when it's not running its risk, it's still got 10,000 cores, and it's still actually, foisted out millions of dollars in order to do that and to pay somebody to be sitting there, not managing the cores while all that's happening, right? You don't need to do that. You could have, say, 30 cores running at any one time, but then when the FSA comes knocking and says, I'm sorry, we need you to provide value at risk, that's not actually how it happens. But once you actually, at the end of the month, have to provide your VAR analysis, then you can suddenly scale up to 1,000 machines, and you'll pay for that at the time. It's a very economical use of compute resource. So actually what it does is it levels the playing field. It means that if you are a small hedge fund, and I mean literally like 4 or 5 guys, you have access on demand to the same power of analysis and the same quality of data as, well, I won't name names, but the tier 1 investment banks. Okay. Andy.
Okay, so George provides services to the financial sector. And what he does is he runs his workload on a high-performance compute grid. And what we do in Elastacloud is provide that grid. Now, I just want to go over a little bit of detail about what we do and how we get that to work. And after we've seen a demo of it working, we'll talk about the actual implementation. So in terms of high-performance compute, what do we mean? We mean that we are trying to break down a large job into smaller jobs, parallelize those smaller jobs, and then stitch the results back together. That's the only thing we're doing in this scenario. If you've got a job which takes 24 hours to run on a single machine, and you can break it down into 24 pieces and put it on 24 machines, the theory goes that if it's embarrassingly parallel, it will take a single hour to do the same amount of work. So you've increased linearly the performance by putting it on more hardware. So that's one type of compute, of high-performance compute you can do. There are others. But in this scenario, we're talking about embarrassingly parallel applications. Now, why is this?
What do you mean by that, embarrassingly parallel?
Embarrassingly parallel. It just means that you can separate it into smaller pieces and then run them all. Yeah. Cut it up and run them on multiple hardware and run it in parallel to gain a performance increase. Why are we using the cloud for this? Well, if you've got to have 24 machines, you don't necessarily want them there all the time. You only want them there for that 1 hour when they're in use. So we're going to use the cloud to provide that provisioning and the elasticity so that if you know you've got a task coming up, you can create those 24 compute nodes, you can distribute your workload to them, and at the end of that computation, you can remove down those 24 nodes to nothing, and you stop paying for your services. But there are other reasons around this, like resilience, security. There are economic reasons, as I mentioned, and there are technical reasons about using very scalable services and building an elastic application design, which give you other benefits. So building for the cloud actually gives you a whole raft of benefits. Next slide. And to classify, George mentioned this before, classify the types of HPC that are available. You can have an on-premise HPC cluster. Maybe the tier 1 investment banks have this already. And it's made of tens, hundreds of thousands of machines. Sat there at all times, you pay for it up front, it's a CapEx. You can have a cloud-based one where you don't have any physical infrastructure. On demand, you create that infrastructure in the cloud, and it's provisioned for you as you need it. And you can have a hybrid approach, and that is you already have a number of on-premise servers, and maybe when you run into some kind of boundary of capacity, you might burst out to the cloud to tackle that capacity issue. But you still have a small number on-premise that does some of the work for you normally. And embarrassingly parallel. What do we have to do in order to make it embarrassingly parallel, to make it actually work? Well, we need to provision compute nodes, and we need a mechanism for distributing work to those compute nodes, and then retrieving the result and somehow stitching it back together. Now, if you can do those two things, then you can have an embarrassingly parallel application which is pretty much transparent to the calling application. It just gets the result back quicker. So when we do a demo, we'll see actually that the user interface isn't looking like it's doing bits and pieces at a time, or any different to how it would do if it was running on a standard synchronous operation rather than the parallel one. And it is simply that the back end is designed in such a way that it is automatically taking those messages, servicing them as and when it can, and then putting the results back on a queue which can be pulled by the user interface, and then just updates itself as it would do normally. Yep. And now into the case study.
Right, so we actually have a very slow internet connection here. So I might actually have to do a bit of a Blue Peter for those of the audience who understand that and show you one I prepared earlier. But we'll just kick this off now and see where that gets us. Hooray, it's visible. It's a very catchy title, this application. Trade blotters are, that's what they're called in the industry. It's basically an inventory mechanism, if you like, for storing trade information and storing the risk and price results from that, and doing a whole lot of other stuff on the side, like scenario analysis and stress testing. So I guess the first thing we need to do here is to open up a portfolio. Now, notice what I'm doing is I'm just going to actually load. This is actually a serialized JSON file, and it contains 200 trades. And these trades are actually in various degrees of complexity. European options, I'll just very quickly explain what these terms mean, although it doesn't really matter for the purpose of demonstration if I explain that. Yeah, cool. Right, so European options are Commonwealth Garden Black-Scholes type things where you have the option to buy or sell shares at a predetermined price, aka the strike at a particular date in the future called the expiry date. Now, ordinarily, that's actually a very simple calculation because there exists a so-called semi-analytic form called the Black-Scholes formula for it. But because I like making my life difficult, I've decided to do it as a Monte Carlo calculation just to sort of show the actual power of this working. All of these positions have got to be funded, usually. So that actually goes through so-called interest rate legs, and they may be fixed rates or floating rates. Floating are generally LIBOR plus some sort of spread. Those are actually very straightforward and to calculate. But again, we're going to calculate them on the clouds just for the hell of it, but you'll see the results coming back very quickly. Variance swaps, again, actually, depending on how you structure these things, they can be calculated very quickly. Because if you do it very simply, they can be constituted as a portfolio of European options. However, generally speaking, you don't want to get killed when your stock goes through a major event. And as you're paying realized variance against some strikes, supposing that's the stock became extremely volatile, you want that to be capped. The moment you put a cap on realized variance, then it no longer exists as an analytic form, and you would have to use Monte Carlo or some more sophisticated analytic form to come up with a price for that. And order callables are probably the worst trade we have here, but very popular in equity derivatives. It's basically where they're really like barrier options. So you basically say, I'll pay you, say 5 years in the future, unless your stock goes above or below some barrier, in which case the thing will terminate early and I will pay you the coupons up to that point, or I can pay you a rolling set of coupons. There are all sorts of variants you can have on this. Again, it's a Monte Carlo trade. Now, the point about these Monte Carlo trades is they tend to be very finely sampled in time. So an order callable will be, say, sampled generally every quarter, going out to 5 years, whereas Whereas a variance swap is actually every single day, and again going out to 5 years. Imagine that we're calculating that with, say, 1,000 Monte Carlo paths. The number of calculations you're going to have to do is going to be quite large, and for every single one of those Monte Carlo calculations, it's actually using something called a local volatility model, which is where volatility has got to move with spot in order to make sure that the European so-called implied option volatility surface is satisfied. Okay, that is the financial spiel over. Suffice to say, these are hard calculations to do, and if we had a lot of time, I would actually show you this running through locally. And roughly speaking, every calculation would take about 3 or 4 seconds. The reason why it takes, it should take about 1 second, but the reason why it takes a little bit longer is because, of course, we've got risks here as well, right? So you've got to bump or shock your underlying assets. And the assets in this particular case are one particular stock, which will be revealed shortly. And within that, I need to bump spot, I need to bump volatilities to come up with respectively delta, gamma, which is a second-order risk, vega, which is a volatility risk. And then theta is actually, how much is it going to be worth tomorrow, all things being equal. It's actually a measure of how well you've hedged your option when you compare it to your gamma. Okay, so nasty calculation up front, even more nasty calculations on the back of that to get your so-called canonical risks out. And that's just the beginning, right? And what we're not showing here is granular shocks. So what happens if I shock the 1 year, 2 year, 3 year points of the rate curves? What happens if I shock volatilities up to 2 years? What happens if I look at the change in curvature or change in slope of the volatility surface? And all these things are actually necessary when it comes to doing deep level value at risk or to do things like P&L explain. My profit and loss changed. Why? Where was it? What is the thing contributing to that? Where was I mishedged? So already you begin to see the scope of the problem. Now, so I'm going to have to sort of move back and forth. So first thing I'll do, hopefully, is I'm going to download some market data. Now, ordinarily, this would take about 2 seconds, but it's a very slow connection. If that comes back, we're in business. If it doesn't, then I'll pull up the one I made earlier. So actually what this is doing is it's gone through all the 200 trades, and it said, OK, what do I need if I wanted to calculate this thing locally? Now, I should point out that in the version of the app we're going to release, you shouldn't have to do this. It should be possible that you can just calculate everything on the cloud. The only reason why I've decided to do it for this demonstration, hooray, came back, probably, is to show you, how we can drill into trades and actually understand what's going on. Okay, so now what I'm going to do is I'm going to just click on Calculate Remote. Now, initially, and I hope only initially, nothing seems to happen. The reason why is it's actually packaging up all of these trades and lots and lots of little messages and putting them onto the service bus, which is then going to get picked up by the cloud. Calculating. Right, here we go. So, cool. These numbers are now coming back, and it's a nice sort of asynchronous mechanism. But what you will see is that, if I were calculating this thing locally, then it wouldn't be going at this speed. It would just be going donk, wait for 4 seconds, donk, wait for another 4 seconds, and so on and so on. And honestly, over a faster internet connection, this whole thing should complete in around about 1 minute. If I were calculating this thing locally, it's about 7 or 8 minutes. We're running this thing actually over 12 nodes, so it's not quite linear. And the reason for that, actually, which we're still working on, is the message gets to the cloud and it says, aha, I need some market data. And it's then got to go off to storage and go and get some market data. So Andy is working on essentially caching around that mechanism, having a distributed cache to make that more efficient. One thing we're also kind of thinking about playing with is that if I had the market data on site, I don't necessarily have to have all 6,000 historical price points coming back if I don't have any calculation which requires historical data. So I can really pin down the market data I need and send smaller packets. That should actually make the process much quicker. You'll see, of course, that the interest rate legs are now calculating very quickly indeed. In actual fact, if I calculated this locally, it would have been donk, like that. It would be immediate. Of course, you're seeing them not calculating immediately because they are being streamed back from the clouds. Just to show you that we're not doing smoke and mirrors, this really is actually going back and forth to the cloud. And you can see, actually, the variance swaps are still calculating because they're such horrible trades. The European options are going to be a little bit faster. And we should be done in around about 10 seconds. Oh, done. Right, good. So there you go. Out the box. I could have just bought an application. In fact, I wouldn't even have to pay for the application. I would have signed up, got an account. This would have been streamed over. It would either use my market data or it would use Derivitec pre-prepared market data, depending on what I've decided to mark. And of course, it's all authenticated against me, so nobody else can actually use this. But notice, I loaded that information in locally. It would have been ordinarily loaded from a database I have sitting locally. The information which is being sent over to the cloud is very, very small. It's no information on Notion. Let's just dive into one of these guys to show you that I'm not lying. There really are a lot of these things around. Okay, so lots and lots and lots of calculations have come back, and I don't send back. I've got a notional of $2 million sitting on this trade. No, what I tell you is dive a little bit further. I tell you that. Somebody will be able to tell me what that stock is in a minute. I'll tell you in a minute. And so I tell you that, okay, it's that in dollars, 29 strike, those, that expiry, it pays there, and it's a call, and I'm going to use Monte Carlo calculation for doing this. And actually, these are the numbers which come back from the cloud. So somebody says, okay, there's just this unit which is worth $2.2, but I haven't told you how much I'm trading. So in that sense, even if somehow you manage to hack into that line, which is something people are worried about, that information would not be valuable to you. You wouldn't even know whether you're long and short that option. You don't know what your net position is. And actually, there's nothing to stop us, frankly, just putting that behind a GUID and having a lookup on the cloud and having the USD behind a GUID as well to make that completely opaque. Probably that's overkill, but again, it can be made like that. And then if I actually go a bit further and I dive into that, aha, now I can actually see what's going on inside this thing. I kind of like this page. So this is Microsoft. As of the 15th of October 2012, its share price has been stable for the last year or so. And this is actually, these are sort of measures that people who trade derivatives care about. So this is the so-called forward curve. And a forward curve is basically a curve of the fair strike of a contract which obliges you to buy shares at a particular price in the future. And it steps down as you have dividends paid, and it rises up as rates increase. And you can see basically that the dividends, I am allowed to say this is public information, the dividend Microsoft has been paying is just about compensating where the quite low level of rates are. And I know they're low level. Why? Because I can dive a little bit further, and I can see what the actual dollar curve looks like. I can get on it. So there you go. Now it's called a yield curve. So this is actually a curve of so-called zero coupon rates. In other words, the rate which corresponds to the discount factor up to that point. And you can see that rates have come down a lot over the last few years since the crisis. And now we sort of tend towards about 2% as we go to very, very long dated contracts, indeed 30, 40-year swaps. And I can see all the supporting information behind it. And I can go deeper and deeper as I like. And actually, when I talk about ease of use with this application, this is another thing people will worry about. This is the so-called vol surface. This is actually where options trade on Microsoft. And you can go down here and you can see what the implied volatilities are and so on and so on. When I talk about ease of use, it means that every time you do a calculation, the information which is going into that is just ready for you. It's done. You haven't had to install anything. You haven't had to provision any database in order to get that information back. And out of the box, you now have a calculation which is using all of that information for coming up with a so-called fair price. In other words, a price at which it would trade in the market, subject to there being no, in theory, arbitrage conditions applicable to that option. So you can't make any free money by hedging the option. Okay. And then, that's just one particular trade type, and we can see, how our MPV is distributed on that particular book, and we can, this mouse has gone bizarre. And we can go all the way down to these horrible structures here, which I was talking about before, which is kind of like that, which is, it gets worse than that, whether in derivatives. But this is a fairly dense structure where you can knock out on a lower level of 71%, a higher barrier of 120%. You can have some kind of overhedge in this. You can have a coupon structure, a rebate structure, and it goes on and on and on. Again, it's just provided to you out of the box. Okay?
Okay. Shall we get the last few slides on?
Yep, sure. In principle. Okay. Okay, that's that. So actually, this was just, I'll just speak to the slide. So this is a bit out in reverse, but that application, I hope, shows you kind of a system that you would use for actual real management of trades, and what you would actually need to do that extensive set of trade types to allow you to have lots of different variants, industry standard models, reliable clean market data, which you saw when I dived into the actual characteristics of Microsoft, And then there are other things around it you'll also need. You need to manage that data process. You need a facility for controlling data. The exchange would actually go out to around about 2 years of 2-year expiries, but your options will generally trade about up to 5-10 years. How do you actually manage that extrapolation process? That we also provide in our software, and that's actually provided as a service in itself. And then, as I say, actually one of the most important things when it comes to looking at portfolios of this complexity is to understand, actually what's going on inside them. So the ability to delve in and pull out what's going on is crucial. So that hopefully demonstrated that. And then just the last point, I think, from me, what do you actually need to do this? Well, you need to go, it's not live yet, but what you would do is you go to our website, you'll say, okay, download a demonstration package of this, plug in your details, try that for 90 days, say, okay, I'm happy with this, I'm going to pay on a monthly basis. That's it. You get provisioned, and that's it. You're away. There's nothing more needs done. And as we expand out our product set, we expand out our model set, and indeed as we actually enhance the app, that will just be provisioned to you on demand. You will move with everybody else. Okay.
Okay. So, just very briefly, as I know we're all eager to get onto this panel. So what we saw there was a lot of compute. And it wasn't always necessarily easy to see. Every single one of those rows that we saw sort of updating has a lot of operations underneath it, and every single one of those operations has lots of calculations within it. It's tier upon tier of calculations. What we did was send lots of messages off to the cloud using the Windows Azure Service Bus. And using that service bus on queues, we had a series 12 compute cores sat there waiting for messages to appear on these queues. And it would pull messages off these queues, and the message says something like, do a particular calculation with a very small piece of input data. It goes off to some various data providers already available to it within the cloud, and it does a calculation, and it returns a message back onto a Windows Azure Service Bus queue. What the client is then doing is looking for those replies on the reply queue so it can pick them up and display them in the UI. What we've done as Elastacloud to enable this HPC scenario is the organization of those grids, the provisioning of those grids, and the connecting of them together, along with the service bus queue as the ingress. Now, we use the service bus because it's very secure and it's very scalable. So it doesn't matter. We don't have to worry if we go from 32 to 320. And it doesn't matter if we go to 3,200. We know that the service bus is going to grow with the messages that we put on it. We also know that Windows Azure is going to be able to provision that number of servers for us. So we can spin up as many as we want on demand through a script and literally just have those servers running for the duration of the business day or whatever it is that we decide to put as rules around this cluster. We can use the Windows Azure Active Directory for authentication, which we didn't show, but to log into George's application, Derivitec's application, you're going to have to provide some credentials, and those credentials are going to come out of Windows Azure Active Directory, and it's going to give some claims as well about the particular company which is involved in running this application, and that's going to isolate things like the grid that it's running on, the particular instance of grids, because we're going to have many grids available for many different customers. And we are building in our model things like self-healing and auto-distribution of these requests so that we're making sure that every single request is put across an entire grid evenly. And if any of those nodes go down, we can spin another one up in its place and it's seamless to the user. Grid functionality. We mentioned very briefly earlier on distributed caches and mechanisms for making this quicker. And we borrowed an idea from Hadoop called data locality, which is that if you're doing work on a certain set of data, then the compute that's doing that work should be pretty close to it as possible. So we're using the Windows Azure distributed cache in order to have on-instance in-memory caching. And we're going to make sure that those nodes which have that cache are actually accessing that cache, and it's not distributed over an entire set of customers. It's only the customers that need that data and running that particular compute that have that cache available to them. And we're using, of course, the Service Management API to enable the spinning up and down of these nodes and to make sure that if anything does go down, we replace the node which has had an error. And just to list all of those things that we're using in this solution, we are using the Service Management API pretty much first and foremost, where most of our work is done. We're using cloud services for the compute, so that's work roles primarily. We're using topics, service bus topics. I was calling them queues before, actually they're topics, so that we can break off subscriptions in a very distributed way and have different services picking up different types of message. And we're using tables and blobs for the market data, so we can access that market data. We, in the future, may plug in things like the virtual network, the Windows Azure virtual network, to allow a VPN between the grid and the on-premise cluster or the on-premise client to enable hybridization with our grid. But that's something which we may do in the future. We're not doing it yet. But you can see that the services available inside Windows Azure means that lots of business opportunities just come out of the box for you. We are using the Active Directory to do authentication. And just rather interesting, and possibly because it's a passion of mine, we are collecting all the logs from all these tens, hundreds, thousands of nodes as text files on a HD Insight server, which is the new name for Hadoop on Azure. So we're using Hadoop to go over these log files and come up with metrics on how well it was running, if there's any kind of recurrent errors, or any kind of periodic delays that we're experiencing with our system, and to guarantee sort of a timeline of uptime on our system.